Recording yourself. Yes, thank you, Carthan. So I think first up, do we want to do one more poll, or do we want to go straight into a talk? Stephanie.
Whatever you say, Madikin, is what I say.
Okay, I think we should go into a talk, and maybe we can do 2 polls after. So I think first up is Maxime, or Matt. You should correct my pronunciation. Maxime Trebich?
Yeah, something like that. Maxime, I guess. Yeah.
Okay, well, I'm really hoping my talk previewed what you're going to show.
Hey, thanks a lot.
Yes, awesome.
Sorry.
Okay, well, you have 5 minutes, and then on deck is Ricardo Beckman.
Okay, let me just try to share the right screen.
Sorry, very quickly. I believe I'm still the moderator, right? So.
Not for the lightning talks.
Oh, okay, good. Okay.
Yeah, sorry, John, you're off the hook for now.
you can join us. You can be a third moderator, but
No, that's quite all right. Sorry, I thought I still was. So.
Yeah, we like to think of ourselves as MCs more than moderators.
Yeah,
at this point.
Yeah, I'm gonna say that's definitely true. MCs, yeah. Live hosts,
right.
So many things. Stand-up comedians. Okay. We're all isolated galaxies right now by ourselves.
Are you seeing the image and the background being?
Yes, yes, we see your whole screen.
Perfect. That's what I wanted. So ideally, what I want to showcase is how I made this kind of image today. And I'm very sorry in advance because most of it is not using YT. I mean, the basic thing is like creating like the 4 different images that I stitched together. And I did that using YT. So like these would be the images, the base images. So these are just projection plots with carefully selected color maps and scalings. So this would be, for instance, gas density in my simulation, gas temperature, showing the hot gas and the cold gas, darker, etc. And so the idea from there was to try to put everything together in one nice image that I could use in virtually all presentations since then, which I've done. And I tried to do that using YT initially, but I tried to do like RGB images, and I was not very confident with it and happy with the results. So I turned back to some more basic tools, in particular Image Magic. So the whole idea is to create a set of masks and like stitch the image together. Yeah, and so the different masks will look like something like this and like that. And then just combining these, you can create crosses, because so far the only way I've understood how to use Image Magic to compose images is to add 2 images with 1 mask and nothing more than that. So I've done several of these, just a few to actually create the masks and add some blurring to the diagonal with a command like that. I will not do the live demo because creating the masks at the full resolution can take a bit of time, but it does work. I just tried yesterday again, it still works, so that's fine. And so once you've created the mask, you just like flip it the other way to get the other direction. So you get from this one, you get that one. And then you can just combine the images together. Wait, actually, maybe I can show what this looks like. Okay, so these 2 images are now created, and they should be these ones. So this is just these 2 images that you create using that mask. And then you just blend them together again using the other direction to get that kind of image, which is kind of cool in itself. And then the next step that I decided to try to do, and I didn't put that on Twitter yet, I think, is to create that, but not just for 1 image, but to rotate these masks all around to create kind of a movie. And yeah, so you just rotate each of the image by whatever factor you want, using this bit of Image Magic where you can duplicate the image and just do a scale rotation translation, I think, transformation. And this is just saying rotate by 2 degrees time step. So you do that 180 times and you get the full rotation. And then the problem is I haven't found how to combine the masks directly on the GIF pictures. So I had to do that image per image, which would look like something like this. But then thankfully you can combine everything, with Image Magic, with FFmpeg again. And you end up with a movie that should look like this. And hopefully this will go well while streaming.
My mind has been blown. This is so cool.
It's like
very
a
happy to
lighthouse of data. I feel like it's a siren song pulling me in.
I'm very happy to share the bash script. And I might have done, I'm not sure, but if not, I will do that again. I will post it on some GitHub or Gist or something.
Or the YT blog.
That would be a good idea as well.
Ooh. Yeah, this is so
That's it
cool.
for me.
That was amazing. I really feel drawn in. You know, extremely hot siren song. Yes. Stephanie, you're muted.
Sorry. No, I'm just making like mouth, like, wow.
Yeah. Yeah. I don't know if you saw when you did the, like, you showed the animations, both Stephanie and I were like, whoa. We were the, like, inflatable people outside the car dealership. That is correct.
Thanks a lot then.
Yeah, that was so cool.
That was so awesome. Thank you so much for showing it. I love that image so much. I think it's great.
Thanks to the community in general for being welcoming. That's really nice for once.
That is my favorite thing about YT.
Yes.
Is
Yes.
hopefully that we are nice.
Hopefully. Yeah. Mhm.
Hopefully not every day. That's for
Yeah.
sure. And my kids would not agree ever.
Yeah.
Um,
But Snape doesn't either behind you.
Snape is just very unimpressed because he doesn't like it when I'm nice.
Oh,
That's why you
okay.
have to have Dumbledore also.
Okay. I see.
Okay, cool. That was so awesome.
Yes.
Let's do a Slido question.
Yes. Slido. Woo.
Okay, so it should pop up if you remember to just keep your window open. You can do like polls or something. Yes. Thank
Ooh.
you.
And the next presenter can go ahead and share their screen so we can
Yep.
do
Next
that while
is
you're slidoing.
and next is Ricardo Beckman. And then on deck is Stephanie.
Cool.
And anybody else who wants to sign up, please do. We're totally in, Okay.
Wow, Baby Shark got some votes.
Well, now everybody's just going to have that stuck in their head for the rest of the day, It's going to be awesome.
Mm-hmm. Although I am very in love with Baby Yoda. I feel like he's cuter in season 2 than he was in season 1. Maybe because he's not like hanging out just like in the egg all the time. So you get to see him more. But I really like Baby Yoda. And if anybody's very into The Mandalorian, we also listen to the recap or like discussions of Mandalorian on this podcast called The Watch, which is in like the Ringer podcast set. And they're very fun and had like a whole discussion about like, don't just shout your baby's name at them constantly. They respond to their name.
I hope everybody is seeing the smack talk happening in chat where Matt said he was old and then I asked if he had laser discs. So everybody, no laser.
I don't have laser discs.
I'm
If I did, I would definitely want is it Dragon's Lair on Laserdisc, one where you push the button to make the little animated.
Oh yeah.
I just want to note that tomorrow, if anybody wants to start early, I'm gonna be about an hour and a half before Rhythm starts. I'll be doing Mando watch through, so just let me know.
Oh, we could do a live
new episode,
watch party.
Yeah.
Sounds great.
Wow.
Well, it seems
I
like
think that
Baby Yoda won by a landslide. Maybe Baby
Yeah.
Yoda used the Force to
I think I'm
win.
the only one that voted for Baby Sinclair.
Wow.
I don't even know who that is. That one went over my head.
Oh,
The
really?
other ones I knew.
Here, I'll send you a couple MP4s.
Okay.
Do you remember
The
that creepy
Jim Henson
dinosaur
show.
show? Yeah, the creepy dinosaur show from the 90s where the baby said, I'm the baby, you gotta love me.
Barney?
No.
Okay.
It's way
No.
creepier.
It
Way
famously had the darkest ending of any family-oriented television show of all time.
Wow.
Hmm.
No, I have no idea what we're talking about right now, but I'm really excited to like dive deep into it. So that'll
Okay,
be a
well,
good
maybe
afternoon
after
activity.
Ricarda.
Yeah. So
Yeah.
Ricardo, I think we've done a lot of smack talk to like, prime people for your talk. So clearly we're ready, I think. So it's all you.
Cool. I just have a fairly small thing I wanted to show. It's nowhere near as cool as what Maxime just showed, but it was one of these sort of, I ran into a scientific problem and I sort of hacked WRIT a little bit to try to do a thing it doesn't natively do. So the problem I was having, it was sort of Stephanie's talk yesterday that reminded me. Let me share my screen. I'm going to have to show you a bunch of different windows. So I'm going to do it like this. So one of my simulations involved a lot of clumps of gas, which is where this sort of the memory yesterday came in. And these are not, the kind of round pressure stripping simulations we saw yesterday, but this is in fact thermally unstable gas in a galaxy cluster. So we're looking at sort of the center of a galaxy cluster here. You can see my screen, right? Just to double check. Yeah, cool. And we have all these really cool gas structures forming. And I wanted to do a lot of analysis on the evolution of these gas clumps over time throughout the simulation. But one of the things I particularly did is I post-processed a bunch of bulk properties, which is fairly easy to do. You can either use the YT clump findings thing, or I used one native to Ramses. So I used Ramses to do the structure finding, and then I computed a bunch of bulk properties. But then the thing I really wanted to do, and that I found particularly helpful for talks, was to try to plot the bulk properties back using the three-dimensional information that is in the simulation. So for example, we got an example here on the left. We just got a sort of classic radial velocity plot, using a cut region on the gas, and you can see it's basically a mess. And then on the right, I've plotted the same gas, but now I've used the structure found information to color code each individual clump by its bulk velocity rather than by the velocity of that individual cell. And that was something that I spent a bit of time trying to think about how to properly do. So I just thought I'd quickly take you through how that works and why I think it's quite useful. So I've just put together a little Jupyter notebook. I'm sorry, no doing it live. I didn't trust myself to do that. So, but basically the idea is fairly simple. We have this complicated gas structure here. For those of you who complain that's not how YT plots, that I've sort of, there was a brief mention yesterday that people said, you find yourself doing the same thing over and over again. And my solution was basically to write my own module that wraps around YT, that presets a load of quantities. So it does things like, annotate a bunch of things to make the kind of plots I use all the time, so I don't have to keep writing the same lines of code. So we have, a density projection, and you can see there's a lot going on with the gas here. So if you do this sort of velocity magnitude plot in this particular example, it's very hard to sort of discern trends in the gas because each cell does something different, and the contrast can be quite large. But I do have all these post-process bulk properties. So I have basically each of these individual clumps is a connected, volume of gas has been assigned a given ID. I have a set of them here. There's less than 100. And one of the things I did is I used in this case, the Ramses clump finder to basically write a custom field where the field is the ID of the clump for each gas cell. So I'm able to just via YT, once I got it to sort of load the extra files, I can plot this. So this is just a plot showing for each clump, basically its ID, and you can see all the cells that are part of a particular structure show up as the same ID on this. And that's really what sort of underlies then the loading in of the other properties. So I need this three-dimensional data structure that contains the clump IDs. And then I have in a separate file here, just in this data object, a long list where with each ID I have associated the bulk properties. In this case, for example, the bulk velocity. And what I want to do is I want to plot the bulk velocity. So what I did is I wrote, a custom YT field. And this is something actually where I have a question where maybe somebody might be able to help, where I use the data object with the bulk properties as a field parameter. So in the beginning of the field, I load the object with all the information in it, and then I load a second field parameter, which tells me which object it is I'm actually trying to look at in this particular case, because obviously I have lots of things. I have anything from the total gas mass to the average metallicity to all sorts of different things. And then I effectively loop over the clump ID, so over the clump IDs rather than the grid, because I only have about 50 clumps, so that's fairly fast. And then I make basically effectively a Boolean mask that selects the cells with that ID already, and then loads the data from the pre-processed information onto the grid like that. And then, you just do the usual YT add field, and then I can plot it like you would plot a normal field. So in this case, I've called it clump velocity, and here we go. That's the plot of the clump velocity, and you can see it's much easier to sort of intuitively understand a lot of the information that comes out this way if you have something like this, in comparison to if we have, the actual sort of cell-based velocity magnitude plot, which is what we got here. It works very well. You can. The way I set it up for myself is I basically have one function that's able to load all the different post-process properties into it. So if I now, add a second field, but this time as say the total dust mass, I can just go through and then plot the total dust mass the same way I did before. The only downside I found is that it tends to override this field. Well, if I do it repeatedly, it overrides this clump field parameter. So this pp clumps is where the whole information arrays are stored. So that one's the same for all fields, but I need to have a way to actually select which particular bulk property I want to pick out. So this one, I use the second field parameter here called clump field. And if I do it repeatedly, it will reset it, so it won't work. So if I want to then again plot the radial velocity.
We're about to lose you. Oh, I thought you were muted. I think you're about to get muted.
Okay.
But go.
Yeah, I'm basically done. So that's handy. Basically, I have to reset the field parameter for this to work if I want to go back to the previous field. So I haven't really found a good way of keeping a memory of that, if I do several fields in a row. But apart from that, it works very well. So if anybody has any insight on how to avoid having to reset this, that would be great, without having to write a custom separate field function.
This was awesome, Ricardo. I love this. I can't believe how beautiful that is. I think
That
that's
was amazing.
like,
I
genius.
loved everything. It was so cool. Also, it looked very like modern art, cool splatter. What's the splatter art guy's name? I can't remember right now.
Jackson Pollock?
Yes. Thank you.
Ooh.
Thank you, Matt. You knew. Mind meld. It was
I know.
cool.
Yeah, that was awesome. If you are interested in extending the conversation, Ricardo, you should totally consider, like, I don't know, posting a link to the notebook. That's a thing people can do, right?
Yeah.
In the Slack, and then because I know you mentioned a couple questions, but it was so fast that I didn't have a chance to like really look at your derived field.
Yeah. Do I just put it on the Slack? Do we have a source for sort of having actual chats for this kind of thing? I'd have to do, it'll take me a minute. I have to get it off the cluster and onto somewhere online so I can share the notebook.
Yeah, no, that's fine. I mean, we can take time. That's a nice thing about Slack. We have so much time before it gets deleted. Although YT is very active, so sometimes we do lose things eventually.
Yeah, I mean, I think for the conversation here, since you presented it, you can put it in the workshop Slack. But after the workshop, maybe you'd want to put it in a different channel.
Mm-hmm.
Yep.
Yeah,
that's good. Will do.
Awesome. Okay. Well, let's do another Slide.io question. Slide.io.
Whoa.
Ooh.
Yes. Ooh. Yeah, this one's hard.
Yeah. A new name.
I feel like a lot of these are inside jokes that I don't get, and
I know
I'm
which one Madikan added.
really enjoying it.
Okay. Well, I'm curious which one you want to know about. I can explain it.
So what's with Ripley?
Oh, okay. So, I chose famous women sci-fi characters, and Ripley is the name of the main character in Aliens.
Yeah. Okay, and then is Dana
canonically,
also?
her daughter is also an alien killer.
Oh, yes, yes. Well, I'm sorry, Matt. An oversight again on my part. So many, you know. Could have a package called, well, Newt, you know, and then adoptive daughter.
So, yeah. So
Okay.
maybe 5 or 6 years ago, I actually did an April Fool's joke where I released a package called XS that was a Fortran wrapper around calling Python functions in YT. And so
Really?
you'd set up your analysis in string inside Fortran, and it'd be all set at compile time and output it.
So what did you name it?
XS, because it was a step backwards. Get it? X. because it's
Wow,
type of-
wow,
Yeah.
wow, wow. Well,
If I had to
it
do
seems,
it, I'd probably call it WS for Wild Stallions now.
wow,
Ah.
wow. Matt, you're just like, wow, on a wild run through the Wild West with your amazing names right now. So Matt, which one did you think I added? Because I added more than half of these. So
I would say yours didn't get any votes.
no, that was when I did not. No, I was most excited about Ripley and Dana because Dana Scully, X-Files.
Oh, really? I was thinking
ultimate.
Dana from
Oh.
Ghostbusters.
Well, also could work. I mean, you know, it's whatever your interpretation is, you know.
I was going with the Sigourney Weaver thread.
Oh, well, you know.
Yeah.
And then, well, A Crash Override is a reference to the wonderful movie Hackers that I encourage everybody to watch.
It's a great movie.
Great movie. You learn so much about computers. So
Yeah. Just like Sneakers. Also, I feel that not enough people
Sneakers
in
is
the
really
world
good.
have watched Sneakers, and everyone should watch it.
I went to a
Fantastic.
conference back in January that had February or January, and they handed out USB drives that just said C-Tech Astronomy on them.
Oh my God. that's so
nice.
good.
Nice.
I tried to get a collaboration to call itself C-Tech Astronomy, and everyone was like, what are you referencing? And I was like, what do you mean, what am I referencing? How are there like 30 people in this room and nobody gets this? It was really sad. So anyway, yeah, I should have put C-Tech Astronomy on this, now that I think of it. Anyway, Groot one, which I'm
Yeah.
really happy about.
So maybe we'll do one more poll question since we don't have anybody signing up after you yet, Stephanie. And then we can, you know,
Cool.
does that sound good?
Yeah. Oh, we got it. It's ready. Here we go. Oh, yay.
Mm.
We had some internal debate on what the right answer to this should be. Wow, that's really sad. Star Trek is beating any sort of Star Wars.
Well, how does this make you feel? Like, I feel like given your and Matt's like back and forth about Star Wars, are you both feeling betrayed right now?
I gotta be able to see who voted for what.
Well, I am very happy with these results. You know.
Yeah, I guess. I don't know. Well, at least now the Last Jedi has tied Star Trek. Although, I mean, there are some fantastic Star Trek movies out there.
5, 3, Insurrection, all the good
Yeah.
ones.
There are.
I don't know why we didn't put the Star Wars Christmas special on here. Like, clearly that's the best one.
I couldn't even make it through the new one.
Okay, well, I'm really impressed with everybody's strong opinions, you know, on all of this. So Stephanie, why don't you get started on your next lightning talk?
Okay. Cool.
And while Stephanie's getting set up, I encourage all of you to sign up. You know, it's okay if you don't have anything prepared. You can do a live demo. as you saw, you know, I struggled with some of mine. And so, you know, it's okay if it's a little intimidating or something. We're all here to support you.
Yeah. Well, and, you know, don't, okay. And, or you can do this, which is, you know, really as low, pretty low level. So I just took a slide from a recent paper that was led by Miao Li, who wasn't able to join the meeting this week. But I just thought it was kind of a cool thing that we did with slices. And so it's just kind of a lesson for me that, you know, it is worth it to just take a look at kind of all of the different fields that you have. So this is some work that Miao has done where we have an idealized galaxy, and we kind of blow up supernovae and we see how that affects the surrounding gas. And the scale here, I think they're 400 kiloparsecs on a side. So we're really kind of looking at the larger scale circumgalactic medium around a Milky Way sized galaxy. And so you have these supernovae blowing up, and you can see all of these kind of like back shocks, and you know, right in the center, the supernovae are heating the gas, and then you have kind of all of this really interesting structure kind of going on that you can see in density and temperature and so on and so forth. But then, you know, this isn't everything. It's a little hard to be able to tell like a coherent story as to what's going on. So, you know, we also took a look at metallicity, which is being dumped in. Metallicity is this center bottom panel, which is being dumped in with every supernova. And you can actually see it's incredibly clean. Like there's still a lot of, you know, shocking happening and back reactions, but actually the outflows are volume filling in this case. And so, you know, there's not a lot of mixing going on between what's being blown out by this galaxy and what was kind of in the original setup of the surrounding medium. So I thought that was interesting to kind of compare this metallicity to like temperature or something. And then the other nice story here is if you look at the Z velocity, you can actually see that although there's a lot of kind of reactions that are, you know, giving us little fluctuations in density and temperature, when you look at the Z velocity, you can actually see these like beautiful big fountain flows. And so where you see these kind of outflows followed by inflows on a much larger scale. And so I just thought that this was a really beautiful figure that she made that kind of showed the use of slice plots. And that's it.
So we have a question in the Slack chat.
Are we allowed to ask questions? Oh, the virial radius is, so this is like a Milky Way, so it's like 300 kiloparsecs.
I think we can ask questions since we don't have like people lined up to go after you. Okay.
Clamoring, they're knocking down the door. Yeah, so it's like it's a Milky Way-esque galaxy. And it's a very cool paper that Miao wrote about this, so you can check it out.
It's beautiful. It's so cool. Maybe you could get all those images and stitch them together with Maxime's script.
That would be amazing.
Yeah.
I love that idea.
Ooh.
Yeah, that would be beautiful. So, okay. Well, since we can ask a question, Maxime, for yours, were you doing like full projections in the box or were they like slabs?
So I think these ones were thick slabs. So like projection, but maybe like 20% deep compared to the waist or something.
Mm-hmm.
Because it's a bit cleaner to have some depth, I find, for the projections.
Yeah, me too. That's very cool. Oh my goodness. Corentin, you got to show us that in a lightning talk.
Yeah, apparently Corentin already reproduced your script in Blender. So. I like it. It's a remix, which, you know, I like it. We can now also do some YT music videos with remixes.
A remix with Blender?
Yes,
what?
exactly.
That was good.
Whoa.
That was really good. Yeah. I like it.
Whoa, I think it'll be great. We can call every single music video Hot Gas, and it'll be great.
The YT Rhythm Band.
The YT
Hot
Rhythm
Gas.
Band, it's just a bunch of cowbells. No, Matt, no. Okay, well, with that, I think we should do another Slido question.
Yes, please. Okay.
Well, I think we know Stephanie wrote this question.
Oh, how are slices beating phase plots?
I'm going
This
to
is-
tell you, as a nuclear engineer, phase plots are not that useful to me.
I feel like you just need to expand your mind, Deacon. I feel like there's got to be a way for a phase plot to be useful to you. I'm so upset because the other cool thing that in this paper that Meow's leading now, we actually found that projections weren't like we couldn't figure out how to look at the data we wanted. So we have this like nice shell that's being formed. And you can do it like with volume rendering. Like if I show you a movie, you can get it, but just like a snapshot of volume
Are
rendering.
you crap talking volume rendering again, Stephanie? This is what
It was
sounds like.
beautiful. It's beautiful. And it turns out you can do some science with it. I showed that. So I'm allowed to say this. But and then a projection wasn't doing it, because you couldn't really tell, if it was the edges of a shell or not. And then slices weren't doing it because it was really not very, it was very fingery. And so, your slices weren't getting kind of enough data. So if we used a phase plot, you could actually beautifully see that it was like right along the edge. If you had like radius versus height, it was so good. So like phase plots beat out projections.
Okay, well, I think in another YT users thing, I'll present some nuclear analysis with YT, and then you can help expand my mind. We will enter the matrix together and
think that's
explore
such a good
phase
idea.
plots. I think it sounds great.
I love that.
It'll be so cool.
But
Okay, so I can't, does the lightning talks go up to 10?
no, just 10. Oh, right. You are at a different hour than I am.
Yeah.
At whatever hour you are, the 45 minutes.
Oh,
I
great.
believe.
Okay. Well, should we
So-
do another Slido?
Yeah, actually, and then I think we're going to a break actually till the 55.
Oh, so we could do
so-
one question and then just start the break early.
Yeah, I think that's a good idea because we've shortened a lot of breaks so we can lengthen
Yeah.
one for people.
Yeah. Oh, yes. I think
Okay.
this is going to be everybody's favorite question.
Nadeekan, what have you done to us? I don't even know what to do.
You have to choose. You have to. Jill refuses to choose, but I know you will. Jill, I know you will.
Yeah, no, I know. I was with you. I put Emacs in and Nadeekan made me take it out
I did.
because she's so mean.
It's true. We were. There's no write-ins. You can't do it. Thank you, Maxime. I agree with you.
Oh yeah. Oh, this is terrible. Wait a minute. What did one of these? That's great.
Wow.
Oh, terrible.
I'm so happy with the popularity of this poll. Thank you, everyone.
You really inspired some strong emotions here.
Yeah.
Ah,
But I think this is a great way to start the break. Jill can already start switching to Vim, clearly the most popular editor. And
oh, horrible. I'm
and it'll go.
devastated.
And Lee is also doing some amazing quality referencing in the chat. So thank you, Lee. That's
Yeah, that's fantastic. Okay, great. So I think we are on break. So this is